Oh, crap, out of gas.
Can you do something for me? Can you do
That must have taken at least 150 seconds. God, busted. Wish there was a way to know how much gas I filled up with. Whatever.
Go buy big gas, hit up tires, save about 10 gallons to get in. We crunk, lit, in the station, yeah. And we walk around the pump, stepping, not giving a driven about the rate of flow, yeah. Get gas mushed, smushed. Yeah, Beamer, the biggest. Put an MVT in the chicken wing, baby. 21, can you do a Riemann sum for me? Can you hit a little integral for me? And 21, can you do a Riemann sum for me? Drop some gas to my tank for me. And 21, can you do a Riemann sum for me? Can you talk to Miss Byrne for me? 21, do your thing, 21, do your thing. Do your thing, 21, yeah, okay.
That was pretty good.
Oh my God, a Riemann sum. That's how I do it. That's what I've been missing this whole time. What is a Riemann sum?
Alright, so Jonah, I heard you're having a little trouble figuring out how many gallons of gas are in your car. So first let me explain to you what the integral of 60 to 135 of FFT dt represents. So that represents the total number of gallons of gas that went into your car between time of 60 and a time of 135. Okay, so now that you understand that, you can use a right Riemann sum with three subintervals from 60 to 90, 90 to 120, and 120 to 135 to calculate this value. Okay, so to set up our right Riemann sum, we're going to use several values from the table provided to us. So if we're going from 60 to 135 and using three subintervals, then the difference between this first subinterval is 30, this one is also 30, and this one is 15. So we're going to need all three of those values. And then because it's a right Riemann sum, we are going to use the right value for each of the subintervals. So for the subinterval 60 to 90, we're using 0.15. For 90 to 120, we're using 0.1. And for 120 to 135, we're using 0.05. So we're also going to need those values for our right Riemann sum. So using those values, you're going to get a setup that looks a little bit like this. And then because this is number 1 on the AP exam, that means you can use your calculator. So once you plug that into your calculator, you're going to get 8.25 gallons. And that's your answer for part A.
Howdy, you mathematicians. I'm back from my rapping career. Kind of failed. I thought it was pretty good. Jonah thought it was pretty good, but I guess the rapping industry just didn't need that big of a hit right now. So anyway, I'm just going to teach you a little bit of math. Part B is asking if there must be a c such that f prime of c is equal to 0 on the integral 60 to 120. What we are given in this problem is that f is a differentiable function. That means that it is also continuous, per the chant DCIB, Mr. Ludwig would love us. So because this is differentiable and implies continuity, this means that the mean value theorem applies. The mean value theorem states that if the slope of the endpoints is equal to a value, there must be a point on that interval such that the slope is equal to that value. So in our case, our endpoints are 60 and 120, which we're given are equal to 0.1 and 0.1. So we're just going to take the slope of the endpoints. We're going to go 0.1 minus 0.1 over 120 minus 60, which is just 0 over 60, which is obviously just 0. So this means that the slope of our endpoints is 0. So per the mean value theorem, there must be a value on 60 to 120 such that f prime of c is equal to 0. AKA a little MVT in the chicken wing action on part B, and that is all we have for part B.
Now, Jonah, you may be wondering, given this equation, what the average rate of the flow of gasoline is on this interval. So if you want to do that, all you have to do is integral over base. So the integral of g of t over the base, which would be 150 minus 0. So this is what the setup would look like. And again, you can use your calculator on this question. So if you plug that into your calculator, you're going to get 0.096 average rate of gallons per second.
So for part D, we're going to try to find out what g prime of 40 is, and we have to interpret the meaning of it. So all we're going to do is we're going to put in g of t, which was used in part C, into math 8. It's going to look like this, dy dx, g of t, and then we're going to put in at x equals 40. This is going to basically take the slope for us at this point, and what we're going to get is negative 0.005. So this number is means that at t equals 40, Jonah's gas pump's rate of flow of gas is decreasing at a rate of 0.005 gallons per second, or gallons per second. From Drake to 21 Savage to Faith, Jonah, and I, we thank you for coming along for our math problem.